So now you can see this is the setup for lysimeter. Here you can see this is the platform which has a weighing mechanism. As I told, you can have any type of weighing mechanism starting from wheatstone based, resistance based, spring condition. Here we have a hydraulic balance. A tube is filled with water which is connected by using these thin tubes, and here we have a scale which measures the head of water. So this is basically a kind of condition where we can say we have a hydraulic balance. This is the lysimeter platform which is standing on a tripod stand basically, but we do not have tripod stand to support this heavy weight, so we are fitting this everything on three table, means wooden platform. You can see first it should be a balanced condition. So you can see it is balanced platform on which we will place a cylinder which is filled with sand. So this is complete setup for weighing type lysimeter, and this is replicating a kind of condition which we have in the field. It is not in the field, but we are calibrating simply by putting the weights of 200 gram each, as I told. So once we are putting the 200 gram weights, it is simply resembling the addition of irrigation or rainwater in the field, and we are observing what is the head. So that is simply the weight. The condition, we are removing the weight, it will give us an idea the water loss from the system because of evapotranspiration. That is our target here. So we need to find out what is the characteristics of addition of water or addition of this weight and removal of the weights or removal of the soil moisture from the actual field. So these characteristics, if we are developing as a calibration condition in the actual field, if we have the weight or say simply the hydraulic head here or the final weight in the field, that we can find out what is the soil moisture condition in the field. So that is our target, and the difference of these two will be the evapotranspiration. So we can find out what is the daily or conditional with time the rate of loss of water from the field because of the process evapotranspiration. So let us put the cylinder filled with sand, and before that we need to find out the measurements. This is the complete setup. We have weighing platform with hydraulic balance. We have sand filled cylinder that is resembling the container filled with actual field condition soil. And we need to find out what is the initial weight. So initial weight we can see here that whatever it is the initial condition, that is suppose 50. What is the angle of this inclined manometer, open manometer? That is 15 degree here. We are taking just one example from this array. This is 15 degree. So we can go for 5 degree, 10 degree, 15 degree, 20, 25, 30, just for an idea. So observation data I will provide you for at least 3 inclination angle of this lysimeter balance arrangement. Initial condition, we put here cylinder, and we need to find out what is the initial weight of this setup. So let me see what is the size of this cylinder. So you can see here we have a size that is 24.5 centimeter is the height. What is the dia? Let me see. Rough method is like here. Okay, I am going that side. So here we can see maximum where it is here. So this is 24 exactly. 24 centimeter is the diameter. 24.5 is the height, and it is filled up to 2.5 centimeter. So the cylinder is filled up to 22 centimeter with the sand, And if we are taking 1.5 gram per cubic centimeter the density of this sand, we can find out what is the initial weight of this cylinder soil. And the initial head is 60 here, 60 in the YouTube. So we can find out the moment we are adding the weight here in distributed manner, how this scale will increase, and when we are removing the weights, that will resemble the use of water from the actual soil condition by evapotranspiration process, it is again reducing the weight. So it should be theoretically equal scale for the weight condition when we are adding and when we are reducing or removing the weights. So let us see whether it is following the same or not. Let us see. So here it is weight, let me put 200 gram. So it starts from 60 to somewhere 60.2. Let me put my glasses. So it is exactly 80.2. So it was initially, you can see again it was 60, and now once we are putting, it is somewhere 80.2. Okay, now put another weight, second weight, it is reaching to 100.1 or 2, 100.2. Third weight, let me put here, and it is reaching to 120, exactly 120. Fourth weight, let us see, it is 800 gram we have put or added water. The scale is somewhere 140.1. So fifth weight, it is 1 kg addition of water. It is 160, 1200 gram. Sixth weight, 180 somewhere. Then 1400, reaching to 200 somewhere. And in this manner, it is 1600, 220 or less than 220, 219 somewhere. Then next we are putting here one more, that is 1800, and now it is 2 kg weight. Once we are adding, it is reaching to near about 256. Now let us see, if we are removing the weights, what is the reading? Let us start from where we have put the last one. We are removing here. It is reduced, but it is not reaching exactly what it was showing. You just see 246.45. Another weight we are removing. This is again 230, but it was something different. The third weight we have removed, it is reaching to 210 or 213, 1213. Now you can see we are removing one by one all these weights slowly, and it gives a reading. So this resembles the removal of soil moisture from the field in the process of evapotranspiration. And if we have characteristics of such kind of soil property, then we can see that it is, we can find out it is the rate of soil moisture removal by the process of evapotranspiration. So now it is the last weight remain as 200 at present, and scale is somewhere 96. So last weight if I removed, this is the characteristics of this scale, that is giving you near about 76, but we started from 60. So this is the characteristics of addition of water and removal of water at 15-degree manometric angle. If you want to see one more, let me show you one more observation, and then I will give you observations to find out the characteristics curve of this lysimeter. Okay. Now let us see. This is new angle 25 degree. Why we are changing this angle? When this is lesser angle, sensitivity of this scale is higher. For the same weight, more divisions will be covered. When we are increasing the angle, sensitivity is reduced. So now see, let us start for 25 degree manometric angle. The starting reading is now somewhere here 45. You can see 45. So let me add the weight here. One weight just 200 gram, and it has reached to 60, near about 6 or say 58. Now the second weight 400 gram if I am adding, it is reaching to 70 or 71. Third weight 600 gram, it is somewhere 84. Fourth weight, it is 800 gram we have added, it has reached to 95 or 96. And this is just 1 kg. Fifth weight I have added, it is 108. Now we add few more weights. Let us see. This is sixth weight, 1200 grams we have added, it is 121. It is 1400 grams we have added, it is 132. It is 1600 gram, one more weight we have added, it is new reading is 145. One more weight we have added and it reached to 156. One more weight if we are adding, it is 170, and now it is 1800 grams we have added, it is reaching to 181, and it is exactly 2 kg we have added, it is 192. So now you can compare between 15 degree and 25 degree. Its sensitivity is reduced now because less number of divisions have moved for the same 2 kg weight. So I am adding one more weight, it is 2200 grams, it is reaching to 205. One more weight, 2400 grams, it is reaching to 215. It is more weight, so it is now reaching to 229. Now let us remove one by one all these weights. So first weight if I am removing, it is not exactly the same what we have added, it is 220, right? So it is little more. Second weight if I remove, it is 210. It is next weight if I am removing, it is 190. See, it was earlier 95 and now it is 98. Now removing more weights, it is reaching to something. Next scale, more weights we are removing, it is 174. One more weight if we remove, it is 162. So in this way, if we are removing weights, now you can see more weight 150, 136, 37, more weights it is 125 near about, 200 removal it is giving 113, again 200 it is 90. 100 exactly, now it is 200 further removed, so it is 88 somewhere. One more we are removing and it is 76. One more weight we removed, it is 65, and finally all the weights now we have removed and reading is somewhere 52. So you can see we have started from different reading and we reached to reduced condition. So in both way, addition of weight and removal of weight gives different reading. This is because of the characteristics of the tube. It is filled with water, and you can explain it by hysteresis losses. You might have learned in your second year. So this is the idea to find out the calibration curve of a real setup of lysimeter, so that the moment we have measured the weight of lysimeter, because it's a weighing type, we can find out what is the content of soil moisture that has been used as evapotranspiration. So I will give you observations for other angles, so you can find out the characteristic curve or calibration curve, and also find out the rate of change, that is tan theta. That's all.